working on a project, and that project goes through different versions over time, and there are a lot of changes that you make to that particular project. And if you want to keep track of all those changes, then you require a version control system. So as the name suggests, it controls the different versions of a particular project. And what is Git? So Git is nothing but a distributed version control system, and that allows you to keep track of changes. Now that change like that allows you to keep track of changes in your code base. Now that code base can be your own self project, or it can be the code base for your organization. In that case, you're like in obviously in an organization there are different collaborators. So the main advantage of Git is that it allows different collaborators to work on a single project, which are no like you don't have to work on a single LAN network or something. The different collaborators can be spread all around the world, and that is the main aim of Git. And this is the basic alphabet or the basic foundation for open source contributions or open source coding. So what do we mean by open source? Open source is nothing but large organizations like VLC or Mozilla. Mozilla being the Firefox browser is from Mozilla. So their code base is open source on GitHub. That means everybody can see that particular code base and can make changes to that code base and can contribute to that code base. So that is what is Git. And yeah, like every organization should have a VCS. Git is the most popular VCS that we have today. Now, let us see some functionality of Git. Let's say you create a file, a normal code, and which has a equal to 1, b equal to 2, c equal to 3. You add a line after some time to that file, and then you remove a line from that. So essentially, you can.
Anshul, sorry to interrupt, but can you just pause for a moment because the limit has crossed 100 and we are starting another meet.
Oh, okay, okay.
Nice, sorry for this, but just give us 5 minutes.
I think we'll use Google Meet mostly. Just wait for 2 minutes.
Okay, am I audible?
Yeah, Pranjan.
Okay then.
Guys, don't scratch
So
the screen, please.
So the participants who are not able to join on Zoom can join the Google Meet. The link must be shared with you, I guess. Okay, so okay, we'll continue. So we were talking about Git and what all Git can do. So let's say you create a file. It has some basic code. A equal to 1, B equal to 2, C equal to 3. Then you add a line in that particular file, and then you remove a line. So to keep track of all these changes, you'll require a version control system, and that is what Git is used for. Let's say you have some code on the GitHub server, and you want to synchronize code between different people. Again, as I said, the main function of Git is to encourage collaboration on a single project. So you can simply synchronize code between different people. It's just like Dropbox for Git, but with much more functionality. Sorry, Dropbox for your codes. Now let's say person A adds some other line A equal to 1 to their code, and person B adds some other change B equal to 4 to their code. Then you can simply merge all of these things on the GitHub server, and we'll look at all of these functions, how you can do that, like simply by pushing and pulling your code from the server. Okay. And again, whatever changes were made on the server will be reflected on your local PCs. So the person B that made the change D equal to 4 is now reflected on the person A's PCs, and vice versa. So this is the main functionality of Git. Now, let's say you are working on your project and you have to try out a new feature. But obviously, if you try out that new feature on the main code base, there may be some problems, because let's say that feature is redundant at a later point of time. Then you have to delete all of those files or all of those extra files and then go back to your code base. Instead, what I can do is you can start the new feature on a different branch. You can continue your old code base. And once, let's say, that feature is successful, you can merge that feature with your main code base. So this is something which is called as branching, and we'll be covering that later as well. Now let us come to the reset or the revert functionality. So again, if you have several changes in your code, you can go back to whatever change. Even if those are months or years old, you can revert back to those codes. So it is essentially a log or a record book of all the changes that you have made in your project over a large period of time. So, and VCS is something which is used by every organization, even organizations like Facebook and Twitter. So let's move on. Now the basic, what is the life of a file? So let us say you are editing a file on a local PC. So you can see the local machine here, and that is what is called as an unstaged area. Now, if you want to reflect that particular change or reflect that particular file in your GitHub or in a particular place where other people can access those codes, then that is what is called as an external remote or GitHub. Now, what is the life of a particular file from your local PC to GitHub is shown using this flowchart. So let's say you are editing a file on your local machine, that is your unstaged area. You add your changes or add your file to a staged area. And then from staged area, so you keep on adding minor changes, small changes to your staged area. And once you have a chunk of changes or a chunk of code, which is, maybe let's say that corresponds to a particular feature, you can commit that feature to commit all of those chunks of changes to the commit section. And once it has been committed, then you can interact with your external remote or github.com. That is the actual servers of GitHub, to either push your code. So push is essentially, if you like, the name is self-explanatory, that you have committed your changes and then you're pushing your changes to the external remote. So this is where the external remote is where other people can access your code. Other people can access your repository, provided that it is a public repository. We'll come to that, what do we mean by a public or a private repository. So, and again, the reverse cycle goes the same way. If you have some particular code on GitHub and you want to bring it to your local machine, then you pull the code from your GitHub repository. So again, we'll be covering all of these in detail. Okay, now, so before we get started with Git, okay, I am assuming that all of you guys have installed Git on your machines. We have provided the links for different operating systems. So once you have installed Git on your PC, be it Windows or Linux, the next thing that you have to do is config Git. So config is nothing but configuring your username and email. So first of all, can somebody confirm if this terminal window is visible or not? Okay, I guess it must be visible. So after you have installed Git, the first thing that you need to do is configure your GitHub on your machine. Now, this is only a one-time thing that you need to do. So to make it a one-time thing, you need to be using a global option here. So essentially, I'll also be explaining some basic command line tools like cd and pwd and ls and all that. Mostly you will be aware of that, but still I'll be covering those. But whenever you have a command in command line interface, you have an option ahead of it, which is denoted by a negative or a double negative sign. And so git conflict global, this particular option will essentially like you will only require this option once in a particular machine where you have installed Git. So now here you can git config global. You can set your username as user.name and then whatever your name is. So let's say put in. Okay, my username has been set, and similarly I can set in my email. Now this information will be very useful when you are looking at commits. So when multiple people are collaborating on a repository, many different people will make different commits to different files. So to keep track of which commit is from which person at which date, all of this needs to be documented, and that is why your config is important. Again, mind you, this is only the first, like this is only a one-time thing on your machine. Once you have done it, you don't need to do it again. Obviously, you can change it, like I am changing it. So you can put in. Okay, so just to check if my name and my email ID has been set, you can find this. So you can see that you can see my name here, and similarly, you can also see my email. Okay, so let's get back to the slides. So git config was the first thing to do. Okay, I wanted to point one thing out. We don't expect you to do this side by side because it will not be possible in this online setup. But it would be great if you could take notes or something. We'll be sharing with you the slides, obviously. But again, like we don't expect you to write these commands in your command line interface side by side. Now let us come to GitHub. So I'll log on to. Okay. Okay, so let us go to github.com. Now, log into github.com and you will have to create your own account. And so once you have created your account, this is how your overview of your profile will look like. So these are your pinned repositories, these are number of contributions, and these are your personal information, email, and the organizations and all. And here you can see your repositories. So repositories are I'll explain what a repository is. Repository is nothing but a particular project. So if you have some project, then you create a different repository for it. Now, for the purpose of this session, we will be creating a new repository on github.com, but you can create a new repository on your local machine and then push it to github.com as well. So let us name this repository any random name. Now this is a repository name. This is the description of your thing. So essentially, your repository corresponds to a project. So you should have a detailed description of what your project is about and what your different files is about. Now the public and private is simply public. If your repository is public, anyone on the internet can see this repository. But the people who can commit it will have to generate a pull request. Again, we'll be covering pull request later. So don't worry about that. Private is something which the repository is only visible to you and not to anyone else on the internet. And these three sections, again, git ignore and licensing will not be very useful to beginners, but I also will not be covering them in this session. A README is nothing but a markdown file, the .md file, which is if you have explored github.com before, you might have seen repositories. And on the main repository page, there is a proper description. There is a very fancy description of all the files that the repository has and what all let's say if you have a particular project, then what is the main.py file and what all requirements you need to install before that. So all of that should be detailed in your README file. So it is very recommended. It is highly recommended that for any project you have a very detailed and visually appealing README file. So for now, we'll not be initializing it with a README file. We'll just be creating an empty repository. So we'll just click on create repository. So this is what the main, this is what a repository looks like. Now, this is just some initial commands of what you can do with this. We'll be covering all of these. But okay, yeah. So the next command that we'll be covering is git clone. So git clone is nothing but cloning. As the name suggests, you are cloning a repository which is available on github.com onto your local PC. So for that, you need to have, so every particular repository has a unique clone ID. And this is the clone ID, which is for this particular repository. And the ID is also pretty straightforward. This is the name of the profile. This is the name of the repository, and this is .git. So this is what a clone ID looks like. You copy this ID, and then you go to your terminal. So I want to clone that repository, which is available on github.com onto my local PC. So now I will type in the command git clone, and then I'll paste the clone ID that I copied from there. Once I click enter, this shows cloning into WnCC Git Workshop. So again, there is a warning here that you have cloned an empty repository because we just created a repository, it did not contain any file. Now, if we go to the okay, I'll cover those basic. So ls is essentially a command which lists, so in whatever directory you are, it will list all of the files and the folders that you have in that particular directory. So ls basically shows this thing. So you can see this in my WnCC folder, I have all these different files, and I can find the WnCC Git Workshop, the repository that we just cloned. Let us change the CD stands for change directory. It changes the directory into, it is used for going into directories and going out of directories, folders. So now you can see ls does not show anything because this is an empty repository. It does not contain anything. So, okay, let me go back to the slides. Yeah, git clone. So git clone is essentially you have some piece of code which is on your, okay, like for our case, it was an empty repository, but it can be any repository that you have. It might obviously not be empty. So if you have some code on your online github.com repository, you can clone it using the clone URL, git clone. This is a terminal CLI, and you can simply clone that particular code onto your local PC. So now let us say I create a new file. So I simply create any test.md. MD stands for markdown file. So I'm just creating a normal markdown file, and this is my file. So I'll just make some changes. Okay. So now I have made the changes. I have saved that particular file. Now if I do ls, I can find that test.md in my particular repository. This repository again corresponds to, you can see whichever repository that we are currently in, it is displayed here. So we are in Git, WnCC Git Workshop. Okay, now we come to another thing. So once we have cloned our repository, we'll make some changes in our local PC. So the change for our current repository is just we have created a new file, and that file just contains some markdown text. Now we add, again, if you refer to the flowchart before, this flowchart, we have created a file in the unstaged area. Now we want to add that particular file to our staged area. And for adding, we'll have to use the function git add. So git add essentially adds my file to the staged area. So now again, okay, I'll show the basic one, git add, and then the name of my file, test.md. So my file has been added to the staged area. Now there are, again, as I said earlier, for any particular command, there are options for the command. So in this particular option, we can also write git add dot. So this essentially means that whatever changes you have made to your whatever files that you have added in your local repository, any changes that you have made, dot will add all of the files at once. So if you are specifying a particular file name, it will only add that particular file. Dot will add all the files in your repository to the staged area. So git add dot will like I only have a single file. I've already added that. So yeah. Now we are in the again going to the flow chart. We are now in the staged area. Now the difference between the staged area and the commit area is that the difference like why do we have a staged area and a commit area? Why can't we directly go from the unstaged to the commit area? Is because let's say you're working on a particular feature and you have some minor changes. So the accumulation of all those minor and whatever minor change that you make, you first add it to the staged area. So the staged area to commit is only for major chunks of code. You don't commit small changes. Like if you are correcting a typo or something, you don't make a different commit for that. And why is that? Because as I said earlier, VCS is storing or keeping track of all the changes that you're making to a particular code base. Now those changes are tracked in terms of commits. So when you're making a commit to a particular file, that commit will be stored in the servers of github.com. And essentially, if you make a commit for very, very small changes like a typo or something, the number of commits can be very large, and you will have a hard time keeping track of changes. So if for a particular code base in 1 month, if you have over 500 commits, then it might be difficult for you to revert back to another commit. So commits are simply for committing or pushing major chunks of code, and this difference will be kept in the history of GitHub or in the history of your repository. So that is the difference. We simply add small changes to the stage area, and then once we have an accumulation of some small changes, we commit those changes to we commit those changes. Yeah. So we have added our file to the staged area. Now we'll commit it. Now committing requires a message with it. So committing has a particular command which looks like this: git commit -m and then the message along with a message of that commit. So you can name that. So I'm like the commit says initialize repo. I am creating my first file, and you can see what it is showing. One file changed, 3 insertions, create mode this, and test MD. Now, what does this essentially? This is essentially the commit ID of your commit. So I'll come back to what commit ID means, but let's focus on commit first. So we have made a file, we added to the staged area, we have committed that changed, we have committed that change, and this is what it shows. Okay. Now we come to the command git diff. So essentially, let's say, okay, I made my changes in file test.md. I committed the file. Now I remember that there was something missing in test.md. So I make a change in test.md by opening the file again. So I'll open the file again, test.md. And yeah, opening the files is, I'm using the Sublime Text code editor. You can use any editor of your choice. So let's say I add another file, another change. And I save this change. I go back to my terminal. And now if I run the command git diff, so again, the name is self-explanatory. Git diff will show you the difference between the changes of that particular file. So you can see what the command line shows. It shows diff --git, then the names of the files that the difference is being shown in. So test.md a, test.md b. So you can see the content of the file as well. Hi, this is a test file, and this is a meaningless text. And the change is this is a meaningless text, and this line is to show git diff. So this is actually the difference between the two files, and that is what the use of git diff is. Now, for this case, we are using git diff to find the difference between two files. But git diff can also be used to find the difference between two branches. Again, as I explained earlier, branches are nothing but okay. I'll explain branches later, and then maybe I'll come back to git diff again. But diff can be used for different cases as well. It can be used to compare between branches. It can be used to compare between files. It can be used to compare between repos, even repositories. So that is the main functionality of git diff. Now we come to git status. So git status is another command. Okay, so if you remember, we had a particular file test.md, we added the file, we committed the file, and we had one file changed. So we committed the file, and then we again changed that file. So if I now put git status, this will show me, first of all, on branch master. The original branch that we start working on is known as the master branch. And again, you can see it shows that changes are not staged for commit. So I had already committed the file, but after committing, I made another change in my file. And that change has yet not been committed or even added to my staged area. So that is why the git status at any point of time will show you what is the status of a particular file that we are working with. So I'm working with test.md. It clearly shows that it is modified. Now let us say I git add. Now again, for adding all the files that in my repo, I simply do git add dot. I do git add, and if I now again click git status, it is now not showing in red, it's highlighted in green. This suggests that what I had modified a file test.md, but now I have added the file. So again, if you can see, changes not staged for commit. This is being shown here. So we first had to stage the change that we have made in the file, and now it is showing that the change is to be committed. So the file is in my staged area. I now need to commit that particular change. So modify test.md. If I now commit the message, commit the change, again, the message can be anything, but it should be relevant to what change that you're making, what thing you're committing. So I am committing a change or a modification in my file. So I'll simply say modify test.md. Okay, so now it shows modify test.md, one file changed, 3 insertions and 1 deletion. So, okay, now if I do git status again, it shows on branch master, your branch is based on origin master, but the upstream is gone. Again, upstream and origin master are related to remotes, which will also be covered later. But the main command is here, nothing to commit, working tree clean. So this is what the changes in git status. First, you had some modified test.md, but it was not staged for commit. Then you add that to your staged area. Then it shows the changes to be committed. Once you commit that change, then you are left with, then you don't have to commit anything. Your working tree is clean. So again, you can identify the analogy. We are working in a tree, and when we go to branches, we are essentially deviating from our code base to start on a new feature, and then we merge it again to our tree. So this is essentially the function of git status. Git status essentially tells you what is your status of different files. Okay, now let's move to the next command. Yeah, so git status essentially on branch master, it is ahead by 1 commit. And okay, okay, let me come back to this git push. Okay, so git push. Now git push, again, the name suggests that whatever changes you have made in your local machine, you want to push those changes to your repository on the GitHub servers or github.com. So essentially, if you remember, we had cloned the repository earlier from github.com, and that is why we can simply type git push and to push our changes to the main code on github.com. So if I simply say git push, again, you can see enumerating objects 6 done, writing objects, and total 6. So essentially, everything has been pushed to this. So to github.com, the monitor be WnCC Git Workshop. So if you remember, our clone ID was essentially this, and this clone ID corresponds to the main repository that we have on GitHub servers. So now the code has been pushed to the GitHub servers. Now, if I switch to the, if I go to github.com and see my repository, you can see if I reload this, yeah. So if I reload this, you can find my change here. It has been pushed to the GitHub. And again, if you see the commit, so this is essentially what commit is. I'll show you the commit history. So you can see the initial commit that I made was with the message initialized repo. And the second commit that I made was modified test.md. Now this is what you mean by, this is what is a commit ID. So commit ID is a 16-digit commit ID, but this only shows the first 7 letters of the ID. So if I click on this particular commit, it will show in green what was added, and it will show in red what was deleted. Or so in the first commit, we only added a particular file with these particular lines. if you go back to the second commit, you can see this line was deleted, this line was added, and there was another line which was added. This line is to show git diff. So and you can see the commit ID. This is actually much longer than 16 digits, but a particular commit is represented only by the first 7 digits of it. So again, you can see that the date is stored, the ID that is stored, and yeah, parent essentially means the previous commit. So this is the second commit that we have. So this is how Git is able to keep track of all the changes that you make to a code base, and that can be like much over much longer periods of time. It can be over years, months, and so on and so forth. Okay. So let us go to the next function, git pull. Okay, so git pull is essentially, okay, now let's go back to, now whatever I showed you was through the command line interface on your local machine. Now whatever the git add commit and all of that can also be done on github.com itself. So I am on my repository, I have a particular file. Let us say I want to edit my file directly on github.com. So you can, okay, so you have your repository, you have a file here, and you can simply click on this edit button to edit this file. Okay, so if now I'll add another line which says that this line is edited on github.com. And if you can see here, again, the functionality is same. You have to commit changes here, but when you are making changes on github.com, you don't really have to add it to a staged area and then commit it. You can directly commit it because you are simply doing it on the GitHub servers. So again, the commit is this. You have to have a message for the commit as well. So added another line. For every commit, you have to have a corresponding message with it. When you are doing it on github.com, you can also have an extended description. Now, it was always suggested that you properly describe whatever commit that you're making, because let's say after a year or so, if another person starts working on that project, then he or she should be able to go back to that commit and understand what that commit was actually about, what changes you made in the code. Okay. Again, branches will be covered later, but this is not important right now. We commit the changes, and now it will show that my particular this is the name of mine. This is the message corresponding to my commit, and this is the commit ID and the date now. So now I have made a change on my github.com Git repository on the GitHub servers, but this will not be reflected in my local repo. If I now open my file sublime test.md, it only shows the 2 lines. It does not show the third line. So what do I do in order to reflect the changes that are present in github.com onto my local machine? I git pull it. So this is, so earlier we had the command git push, which essentially pushes the changes on my local repository to the GitHub servers. Now I am pulling the changes from GitHub servers to my local PC. So I'll simply do git pull. So again, you can see from this particular ID, from the same ID, which was the clone ID, we have pulled our changes. Test.md, 1 file change, 3 insertions, and 1 deletion. If now I open my file again, test.md, I will see those changes. You can see this is a new line that I added on GitHub servers, and now it is reflected on my local PC as well. So this is the basic functionality of git pull and git push. So the main advantage of git pull is, for now, I myself made the changes in the repository, but let's say you have a project on which multiple people are collaborating, and you have cloned that particular project on your local PC, but after cloning, obviously other people will keep on adding commits. So if you want to reflect those commits, if you want to reflect those changes again on your local PC, you will keep on git pulling from the GitHub servers. So git pull is a repetitive command which you should often, like you should run it pretty often so that your repository stays updated. So that is what git pull is. Okay, I forgot to mention one thing. If you go back to this.
Pranjal, just one thing. Can you
Yeah.
clear your terminal because it's not visible actually?
Oh, okay.
Yeah, that's it. So just keep on clearing it when you reach the bottom.
Okay, sure. So there is one thing we can do here. Again, the main aim of Git is to add collaborators, right? So if you are the owner of any particular repository, I made this repository in front of you right now. I am the owner. I can go into settings. I can click on manage access. Now there are a bunch of settings here. You can look into them on your own. But the main thing is manage access. Now, if you want to add a particular collaborator, let us say I want to add Abhishek as my collaborator. He wants to me and him are collaborating on a particular project. So I'll say invite a collaborator, and I'll type in his ID. Yeah. So I'll add Abhishek Payangle to this particular repository. So now he has been added as a collaborator on the repository. So now because he's a collaborator, what he can do is he can now also make changes to this particular code. And again, as I was saying, if there is a project on which multiple people are working on, then in order to keep your local machine repository updated, you need to git pull frequently so that whatever changes are added on by other people are reflected on a local PC as well. Okay. So git pull is done. Now we come to git log. Okay, so for git log, I would suggest that Abhishek, if you are hearing this, can you make a change onto that particular repository? So I just added Abhishek as a collaborator. So he can make changes to this particular file, or he can add another file. He can do anything with the particular with the code of this project. Okay. Okay, we will rather skip that for now. So let us say he added another commit to this. I'll git pull it, and I can show the changes in my local code. Now git log is a command which essentially, again, the name suggests that it will keep a log. It will show you a log of the different commits made in that particular repository. So if I do git log, you can see here the different commits that have been made from the starting till the end. So okay, just a second. I hope this is visible now. So again, if you remember in the beginning, we did git config in which I set up my name and my email ID. So this is why it is useful, because when different people are collaborating on the same project, they should be aware of who was the author of the particular commit and when was this change committed. So you can see Sunday, September 6, 2:44 and 2 seconds. This was the time of the commit. This is the message of the commit, and this is the commit ID. So this was the commit ID. So this particular command git log shows you the different commits that have been made till now. This was the initial commit, which was with the message initialized repo. Then we have another commit, modified test.md, and this is the latest commit that we had added another line. Now, if let's say Abhishek had to commit, and if I pull the code again from GitHub servers, I'll also see Abhishek's name here. So the author will be Abhishek Bayangle, his email ID, the date will be the same, and his whatever change he made, he can that will be displayed here. So that is the main use of git log. Okay, so you can see here when we press git log, we can have the particular commit message, the commit ID, the author, the email ID, and the date. Right, so we can have different people collaborating on the same thing, and all of that is stored in the log. Okay, now we come to git reset. So again, the git reset, as the name suggests, is for resetting to a particular commit in behind in commit which was made earlier in my code. So let us say I have made 3 commits, and after making the 3rd commit, I find there is some problem in my old code which I have to change in after my 2nd commit. So essentially, I just have to delete my 3rd commit, and I have to revert back or reset back to my 2nd commit. So what I can do here is, so I am currently I have made 3 commits, and I am currently at this particular commit, right? Even the So this thing essentially means that I'm at this particular commit. If I want to switch back to this commit, whatever changes were made in the second commit, I'll simply type git reset.
Hello, Pranjal.
Yeah. Yes.
Yeah, so you can show the git log now.
Okay. So I think Abhishek has made a change in the main repository on github.com. I'll pull the changes again just to just to reflect his changes. Let me clear it. I've pulled the changes on my local computer. If I now press git log, you can see there was 3 commits from my side, and the 4th commit was from a new author, Abhishek Payangle. His email ID is here, and the date when he made that commit is here. This is the name of this is the message corresponding to this commit. So this is how git log works. You can have different people, and then they can collaborate. And okay, now let us say I want to reset my second commit. So what I can type in is I type git, and now I can put in my commit ID. So essentially, this is what a commit ID is used for. You can go back to a particular commit using that commit ID. So I can type this. I can copy this and I can paste it here. So you can see here, head is now modified, is now at this particular commit, which is again the first 7 letters of my commit ID, modified test.md. So yeah, so this is how essentially, if you again check git log, yes, only 2 commits are being shown here. Initially we had 4 commits, now only 2 commits are being shown, and my head is at the second commit, which is what I wanted. If I now check my file, you can only see the changes that were made in the second commit, right? In the third commit, we had added another line, but that is not shown here. So this is how you can reset back to a particular commit. Again, this is very useful when you are working on large code bases. This essentially shows that you have added a line and then you want to remove a line, and this git reset, you type in the commit ID and then you go back to that particular commit. Okay, now we come to making changes. So this is the place. Okay, let us say I start with my first commit. I start with a project. I make my first commit. I do some changes. Then I make more changes. And then I again commit it. Now what I'm doing is I'm starting a new feature in the same particular tree, or you can say in the same particular code base. And I keep working on the new feature. But there may be a case wherein I let that feature out. So I can go back to this commit before I started the new feature, or maybe there are some more changes which are required in this particular feature. But excuse me. So till I am working on my new feature, no other collaborator can actually make changes, or no other collaborator can actually merge their new changes with the main code base. So that is why we have a concept of branching here. Branching allows you to make changes into different start a new change, or play around with the code base, but not actually affecting your original working tree. So you can start a new feature in a different branch. You can then keep working on that new feature, but in a different branch, but at the same time allowing other people to work on the main code base. And let's say you fix a particular bug. Again, this will not cause a problem because there is no conflict between the new feature that you're working in and the bug that you want to add, or anything that you want to do to your main code base. So now the branches are named as master. So the main branch that you start with, whenever you initialize a repository and whenever you start making any changes, the branch that you are currently working in, the main branch is known as the master branch. And whenever you make a new branch, you can obviously give it any name. Let's say I give it the name feature. So these are the 2 branches. I have one branch as feature. I have one branch as master. Now this is what you call as a head pointer. So head pointer is nothing but just a representation of which branch I'm currently working in. So if head points to master, I'm currently working in master, and whatever changes I will make will be reflected in the master branch. If head is on feature, then whatever changes I make will be reflected only in the feature branch and will not be reflected in the master branch. So now what you can do is, let's say your feature gets completed, it is a successful addition, and then you can merge that particular thing with your main code base. So this is where the merging comes into play. So again, I'll just briefly revise it. We start with the first, we start with the master branch. Then we want to start working on a new feature. We start on a new branch, and then we simply merge that branch if it is a successful thing. Okay. So branching involves these three commands: git branch, git checkout, and git merge. I'll show you these on the interface. Okay. So if I type in git branch for now, you can see there is only a single branch, which is shown by master, and the star basically denotes my head pointer. The thing that I showed you earlier, the head pointer is denoted by star here. So you can see my star is at master. Yeah. Now let's say I want to create another branch with the name of new branch. So what command I'll use is, okay. Yeah. What command I'll use is, I'll use git checkout -b. Now this essentially denotes that we are referring to a new branch. We want to create a new branch, and this is the name of your new branch. So let's say new branch. So this is now saying switch to a new branch, the name of the branch, which is again new branch. If I again type in branch, you can see here we have two branches now, the master branch and the new branch, and my star or the head pointer is at the new branch. So this is how you create branches. And yeah, so this is like git branch and git checkout is used like this. Now let us say I create another file in this branch. Let me so okay, I created this particular file, and in my new branch, now if I ls, so ls is actually pointing to the repository, so it will all, show you both all the files in all of your branches. So this test.md is in my master branch, and test new branch is in my new branch. Okay, now let us say I wanted to merge these two branches. Test new branch is my new file, and this is working perfectly. So I want to merge this particular branch with my older branch or with my master branch. So I'll type in the command git. Okay, for merging, I'll have to switch back to the master branch. So let's say I want to merge the new branch with my master branch. So I should be on the master branch, and then I'll actually type in the command for merging. So how do I store another branch? I will simply type in again git checkout. Now I'll not type -b because -b was for create new branch. I'll simply type in the name of the branch to which I want to switch to. So git checkout master. So again, it shows switch to branch master. Your branch is behind origin master by 2 commits. So this origin master also will be covered later when we come on to remotes. But origin master essentially points to the main repo that we have on the GitHub server, the one from which we pulled our code. That is what the origin is, because first we created the repo on the GitHub servers and then we cloned into it, right? So the origin points to that thing. So now we are on the master branch. Again, if you type in git branch, you can see the pointer. We have 2 branches, new branch and master, and the pointer is on my master branch. Now I can merge these branches using the command git merge, and I can then type in the name of the branch that I want to merge. So that is new branch. Just a second. Yeah, so if I type in git merge, yeah, actually you don't need to type in the name of the branch that you want to merge. You simply type git merge, and whatever branches that you have except from your master branch will be merged. Now, if I type in git, yeah, if I type in git branch again, you can see the branch has been switched to master. Sorry, it was already at master, but the file from new branch has been now moved to master. You can see the one change denoted here, 1 file changed, 5 insertions and 1 deletion. And now because all of my changes have been merged from my new branch to the master branch, I can simply delete my new branch. So to delete a branch, you simply type git branch minus t and the name of the branch that you want to delete. So this is essentially deleted branch, new branch, and this thing. So if I do ls, I have two files, test.md and test new branch, and yeah, and both of these files are now in my master branch. Okay, if I type in git log again, okay, this will only show you the commits. So yep, that's it. So after this, we'll be covering conflicts. So essentially, conflicts can arise whenever you merge two branches. And so let's say you are working on test.md on the master branch, and you're also working on a similar name file test.md on a new branch. But when you merge those two branches, then there may be some conflict, right? A particular line may have some different value in the master branch, and that particular line may have a different value in the new branch. So Abhishek will be covering from here on now. I think I have covered whatever. Yeah.
Yeah, you can push the changes.
Oh, sure. Yeah, I'll push the changes. Cool. So I'll simply type git push. Yeah. So it does now push whatever changes I had made in my local computer to the main repo on GitHub servers. Yep, that's it. So Abhishek, you can take over from now.
Yeah. So I'll start screen sharing this.
Okay.
Okay, so am I audible? Hello.
Yes, go ahead, go ahead, go ahead.
So basically, I'll
So someone
see
was
the
asking
changes on
about
the.
using Git on a terminal. So you just show your bash once.
Yeah, I'll show you. So basically, this is a Git bash. Okay, so you can see the slides. Hello.
Yes, the slides are visible. Continue.
Okay, cool. So basically, merge conflict happens when if someone commits a change on a GitHub.com, and then you have also edited the file, and then when you try to merge both of them, they can occur conflicts. So yeah, so wait, I'll first demonstrate the git conflict, merge conflicts. Okay, so this one is version of the file on github.com. So I'll first make a change on github.com. This can also be made by other collaborators. For instance, Pranjal can, or Pranjal or anyone can make a change. I'll just say a equal to 2 for this one. I'll write a equal to 2 on this one. Yeah, so on github.com, now it's a equal to 2. So now I'll go on my local version of the file. I haven't pulled it yet. So here what I'll do is I'll write a equal to 4 and then save the file. I'll go to the terminal. I'll git add I'll commit the changes, and now if I pull the version of the file that is there on github.com, so if you see, yeah, so now as you can see here, there's a conflict, right? So on on github.com, it's a equal to 2, and on my local version of the file, this a equal to 4. So what happens is basically in the text editor, it shows what is the version of version of the conflict on your local repository, and the one that is there on the github.com. So now what you can do here is for VS Code, they have given an interface that we can choose whether to accept the current change or accept incoming, or accept both the changes. But what you basically have to do is you have to manually edit manually edit it and keep one and discard the other ones. So I'll keep the a equal to 4 one and I'll discard a equal to 2. So I'll save it. And now I'll add the changes again. Yeah, so now I've solved the merge conflict on my local PC and added the changes to GitHub. So it was a equal to 2 here, and now yeah, it's a equal to 4. So I've merged the conflict on my local PC. So you already seen this, that the conflict appears like this, and then you have to manually edit it. So yeah, now coming to the remotes. So basically remotes are repositories on which multiple people can work. On local repository, you cannot really have multiple people working on it. So that's why on the repository on GitHub or any Bitbucket or any on the repositories which are on online servers, they are known as remotes. So you can see all the remotes that are there by typing this command. Yeah, so this shows both. This is the same remote actually, but it shows the two versions of it. One for the fetching. Fetching is I'll explain it. Fetching is same as almost same as pulling, and push is for sending away your files from local to GitHub. Yeah. So now let's come to git fetch. So git fetch is a command which if you type, what happens is all the changes on the remote will be fetched on your local repository, but it won't be merged. So it will just fetch all the changes and it will show you the changes. Okay, and when you type git merge origin master, so origin is basically the remote repository from which you have cloned your local version. So origin, the master branch of origin will be fetched on your local PC, and it won't be merged. So after you type git merge origin master, the master branch of your local PC will be merged with the origin master. So we usually don't use this. So what is the alternative for this is we just type git pull. So git pull is basically git fetch plus git merge. Okay, so I'll demonstrate this. I'll make some changes on the on the remote version of this repository, that is the one available on GitHub. And then come to the terminal. I'll do a git fetch. Yeah, so git fetch is just pulled, like fetched all the files from GitHub, but it hasn't merged with my local version. So I'll do a git merge. So yeah, now as you can see here, it is mentioned test.md1 plus. So I've added a one line, so it says 1 plus. So now the changes are reflected on my local version of it. Yeah, basically to it, the one that I added on github.com. Okay, coming to the next part is forks. So this one is pretty important part, because if you are really working on a project, then you will need to do a fork, or if you are doing open source or something, then you need to fork. You have to use this fork. So basically, fork means it's generating a personal copy of someone else's repository. Okay, so this one is Pranjal's GitHub. So I'll just open any one of his repository which I want to work on. This is already forked. Yeah, so this is one of the public repository of Pranjal. So what I'll do is there is a fork option here, and I'll click this. Yeah, so these are my organizations. I'll prefer to fork it to my GitHub account. Yeah, so now it's forking Pranjal's my first blog repository, and it is creating a copy of this repository on my GitHub account. So yeah, now you can see Abhi Pangle and my first blogs forked from the monitor B, my first blog. So this is my version of his repository. Okay, so this is basically done so that I can add a feature or whatever changes I have to make to this, and then I can uh, set a pull request. I'll explain pull request in detail. Okay. Yeah. Now what I can do is I can go to the location where I want to clone this repository. Now this is basically the same process that you have seen while cloning a repository and working on it. Yeah, so now I'm into this, where is it, my first, yeah, so this is a repository. I'll open it on my text editor. It's taking time, just a minute. Yeah, so now you can see these are all the files. What I'll do is I'll just add a readme to this file. So it is let me see hello. So you can actually work on projects by adding different features on your local version of others repositories. Now it's the same process, git add. So git add dot is basically adding all the changes in that repository. So instead of git push, I can also do git push origin master. So basically, okay, I cannot make changes to uh, origin master because origin master resides in Pranjal's GitHub account and I don't have access to that. So I'll do a git push to my version of his repository. So let's go to GitHub.
Abhishek, actually you have a typo there. It should be git push origin space master. I think it would work.
Okay. Yeah, cool. So now there are no changes, so it's not adding any changes, but yeah, this will work because yeah, everything up to date shows. Cool. So
Sorry to interrupt. The reason is actually Origin is his own repository. The the original repository that he had forked from is not Origin. It is like you'll have to set up the remote for that separately. But git push origin master in this particular case, git push origin master and git push is similar because he had cloned the repository.
yeah. So when I clone the repository, so this is my origin basically, and this is, it shows here it's forked from monitor B, but yeah, this is my this is the origin because I cloned it from here. Yeah. So now it shows changes on my version of his repository. That is, it shows the README that I've added. But if I go to his repository, it won't show any changes. So basically, this is done so that if there is some project, for example, if there is, okay, so Facebook's main project is there on GitHub. Just say if it's there, and you want to add a new feature to the Facebook's, say any feature to Facebook's navigation bar or something. So what you can basically do is you can fork in their repo, add all the features that you want on your version of the repository, and then you can generate a pull request. So coming to pull request is it's submitting all your contributions to the main project. So the project, I mean the repository here. So if I want to reflect all the changes that I've made on the main version of it, that is on the Pranjal's repository, I'll say pull request. So it will check mergeability. Basically, checking mergeability is if there are any conflicts. The conflict that I've showed on local version, they can also occur when merging two repositories on GitHub, merging two branches on GitHub. So now there are no conflicts. Okay, it's just a new file, and yeah, this is hello. And I'll create pull request. You can write a title here and leave a comment, as in basically you have to mention what all changes you have committed. Yeah, so now there's one pull request on his version of it, but until and unless he accepts it, these changes won't be reflected. So he has to accept all the changes that I have made to his repository, and then if he thinks that the changes are good, I mean if he wants the changes, then he'll accept it or just close the pull request. Okay. So there can occur an instance where your version of fork is uh, behind by so many commits from the main version. For example, this was the learner space. The courses were conducted, and I was one of the contributor. And I had contributed until so say week 4 out of week 6. So after that, I did not make any pull request. So if it is still the forked version is still there on my GitHub account, it will show here that the branch is 69 commits behind WnCC master. So the master branch of the WnCC's learner space repository is 69 commits ahead. And if I want to reflect all the changes on the main repository on my version of it, I again have to do a pull request. But this is like a reverse pull request. So here it shows Avipangli learner space master to WnCC learner space. So I have to do the opposite of it. I want to get all the changes from WnCC's learner space to Abhipangli's learner space GitHub repository. So what I'll do is I'll click this option, switching the base. So when I do this, it will check mergeability. Yeah, so there are no conflicts, and here it shows all the commits that have occurred since the last time you forked the repository. Yeah, so these are all the commits that have occurred in between, and all those commits do not have a merge conflict, so they are able to merge. So then you can create a pull request. Yeah, so here is a pull request on my version of it, and now I have the right to whether accept this pull request or reject this pull request. Pull request can be generated by anyone on any public repository, but then the rights are only given to the all the contributors whether to accept that pull request and merge all the new changes into your project or whether to just reject it. So I can see all the changes here that are made. Yeah, it says that this branch has no conflicts with the base branch, so it can be easily merged. There are no conflicts. So yeah, I'll just merge the pull request. Just leave a comment. it shows merged here. That means if I go to the code now, this shows the branch is one commit ahead. Yeah, that is because I just typed in a comment. So that was considered as a one commit. Okay, so basically all the changes that were made, all the 69 commits that were made on WnCC master have reflected into my version of it. So this is done so that if you are working on some feature and someone else is also working on that feature, and you want to see what his features, what he has changed to the project, and you want to you know, work further on that project, like add some extra features, then then you can fork, like you can generate a reverse pull request, and then you can continue from where he has stopped. So that can be just one. Yeah, there is just one way, to generate the reverse pull request. Okay. Okay, so GitHub walkthrough. So GitHub is basically uh, it's a it's a big server, it's a big database where there are so many repositories, so many projects on which people are working, and you can contribute to any project that will come into open source. I'm not going deep into open source, but uh, if you go here into explore, or if you go to any of your friends or colleagues repositories, and if you think that these repositories are, you want to get updated by this, get updated on based on what happens to this repository, so what you can do is you can either star it or watch it. When you watch it, you will get notifications of all the pull requests that are getting merged, and anything that happens in the repository. So if I uh, select the option watching, if there are any changes that occur to this, I'll get a notification. Uh, Star is also similar, but in Star, it doesn't, spam your notifications. So if you are interested in any of the public repositories that are there on GitHub, you can just star it or watch it. Okay. What else? If you have an organization, or if you have like 4 or 5 people working on a project, what you can do is, instead of forming a repository, you can make a new organization. So for example, this WnCC is an organization. It's not a personal repository of anyone. This is an organization. So an organization, you can have many people working. You can add many contributors. You can make different teams. You can start projects. So these are basically features of an organization. But yeah, this is little about basics. So yeah, I think that's it.
Okay. So I think we have come to the end of the session.